All right, let's jump right in. We're about to take a tour of what might be the most complex, most mind-bogglingly fast construction project in the entire universe, the human brain during its first 8 years of life. It is an absolutely explosive period of growth that really lays the foundation for everything that comes after.
And just to give you an idea of the kind of speed we're talking about, look at this number. 100,000. That's how many new neural cells are being grown every single second in the fetal brain. It's a pace that is almost impossible to wrap your head around, and guess what? It's just the very beginning.
So here's our game plan. Think of this as an architectural tour. First, we'll meet the tiny workers doing all the heavy lifting, the neurons. Then we'll zoom out to see the major structures and the 4 main departments of our thinking cap. After that, we'll follow the construction timeline, from before birth all the way to those wild toddler years. And we'll finish up by seeing how our own unique experiences actually sculpt the final masterpiece. Sound good? Let's go.
Okay, first stop, we're zooming way in to meet the absolute star of the show. This is the fundamental building block for every single thought, feeling, and action you've ever had, the neuron.
So what is a neuron, really? You can think of it like a tiny living electrical wire. It's a super specialized cell that's built for one thing: transmitting information. Every memory you have, every decision you make, all of it comes down to these little guys firing off signals in incredibly complex patterns.
Let's break it down real quick. The dendrites, they're the listeners, like little antennas picking up signals. The axon is the talker. It's a long cable that sends the message out. And the synapse is where the real magic happens. It's this tiny, microscopic gap where the signal has to jump from one neuron to the next. That's what we mean when we say our brain cells are firing.
Now, how does the brain get fast? Well, an axon can send a signal by itself, sure, but it's kind of like a slow walk. To really crank up the speed, the brain wraps the axon in this fatty coating called a myelin sheath. This stuff is an amazing insulator. It allows the electrical signal to just jump from one gap in the coating to the next. Seriously, imagine walking down a sidewalk versus jumping from one square to the next. The jumper gets there so much faster. That's myelin at work, making our brains lightning quick and super efficient.
Okay, so we've met the workers. Now let's zoom out and take a look at the grand architecture, the actual blueprint of the brain itself. Way down at the base, you've got the core systems that basically run the whole show on autopilot. The medulla oblongata, that's your life support. It handles your breathing, your heartbeat, the stuff you don't want to have to think about. The cerebellum, which means little brain, is the master of coordination and balance. Then you've got the pons and midbrain, which are like the central dispatch, routing all the messages. And then there's the main event, the cerebrum. This is the biggest part, and it's where all our higher-level thinking happens.
So let's zoom in on that main event, the cerebrum. Specifically, we're going to look at its wrinkly outer layer, the cerebral cortex. This is your thinking cap, and it's divided into 4 specialized zones, or lobes, where pretty much all of your conscious experience gets processed.
And each of these lobes has a special job. All the way in the back, the occipital lobe is your visual cortex. It handles everything you see. Up top, the parietal lobe deals with sensation, touch, taste, temperature. On the sides, the temporal lobes are all about sound and language. And right up front, the big one, the frontal lobe. This is the CEO of the brain, managing things like decision-making, problem-solving, and paying attention.
Let's stick with that parietal lobe for a second, the one that handles touch. It actually contains a map of your entire body. But here's the catch. This map is not to scale. So let me ask you, what do you think that map would look like?
It would look something like this. This strange-looking fellow is called the sensory homunculus. It's a fantastic illustration of what the brain actually prioritizes. It's a distorted map because the size of each body part isn't based on its physical size, but on how sensitive it is. So why the wacky proportions? Well, it's all about function. Just look at the size of the hands and lips. They get a massive amount of brain real estate dedicated to them because they're our primary tools for exploring the world. We basically see with our hands, gathering all this rich information. And our face is super sensitive to protect our eyes, our ears, and of course the brain itself. It all makes perfect sense when you think about it. All right, now that we know the basic layout, let's get into the construction timeline. And this whole project starts long before a baby is even born, orchestrated by 6 critical biological steps that build the brain's foundation from the inside out. This is the genetically programmed sequence for building a brain. First up, proliferation. That's just a frenzy of new cell creation.
Then, differentiation, where these new cells get their specific job assignments. After that is migration. Each neuron has to travel to its correct spot in the brain. Then comes synaptogenesis. This is where they all start connecting with each other. Myelination is next, which is that fatty coating we talked about that makes everything faster. And finally, pruning. This is the cleanup crew, getting rid of unused connections to make the whole system run better.
Now, once a baby is born, the brain just kicks into overdrive. We enter this really dramatic boom and bust cycle. It all starts with a massive explosion of new connections as a toddler starts to experience the world for the very first time.
And get this, by about age 3, a child's brain is absolutely jam-packed. It is more dense with connections than it will ever be again in their entire life. Think about it, the brain doesn't know what's going to be important yet, so its strategy is just connect everything. Every new sight, every new sound, it all forges a new pathway.
But that insane level of density just isn't sustainable. So the brain begins the bust phase. It's called synaptic pruning. The perfect analogy is a gardener trimming a rosebush. You snip off the weak little branches so that the main strong ones can flourish, right? The brain does exactly the same thing. It gets rid of connections that aren't being used, which frees up resources for the pathways that are used all the time, making them stronger and faster. It is literally use it or lose it.
And all of this brings us to our final stop on the tour, seeing how life itself becomes the chief architect. This is where the genetic blueprint meets the real world, and a person's individual experiences start to sculpt their completely unique brain.
So experience shapes the brain in 2 main ways. First, there's experience-expected development. This is the brain's built-in anticipation of universal human stuff, like seeing faces or hearing speech. It's pre-wired for it. But then there's experience-dependent development. This is what makes you, you. These are the unique connections built from your personal life story, the memory of your first pet, the smell of your grandmother's kitchen, all of it.
What makes these early years so incredibly important is this idea of critical windows. For certain skills like learning a language or developing proper 3D vision, the brain needs specific input during a specific window of time. If it doesn't get that input, that ability might never develop properly, or at least not as well. This is why things like talking and reading to young kids aren't just nice things to do. They are a biological necessity for building a healthy, functioning brain.
So there you have it. From a single, tiny neuron to a complex mind sculpted by a lifetime of stories, that is how a brain is built. It's a construction project that never really stops. Every day, our experiences continue to shape it. The big takeaway here is that our brains are literally designed to learn from the world around us, which really leaves us with just one final thought. Knowing that, what are you going to teach your brain next?